Alright, so this lesson is the 6.4 lesson. It's about solving equations that have rationals in them, so ratios, fractions. So pause the video, spend a little bit of time working on the warm-up. These are all skills that will help you with the lesson today. So if you're able to do these on your own, you're going to understand the content today much better. So pause the video, try them, and then come back and check to see how you did. So the first few here are equations. We solve equations by undoing operations, so doing the opposite of what we see. So when we undo things, we do order of operations backwards. So we'd be adding and subtracting first, then multiplying, dividing, then exponents and grouping symbols. If we're simplifying an expression, so if it didn't have an equal sign, we'd be using order of operations, GEMDAS, to do that. So just keep that in mind. Inverse operations is for solving. Order of operations is for simplifying. All right. The next one is what we did in our first lesson, our 6.2 lesson. We were multiplying and dividing. So when we multiply fractions together, we just multiply straight across. With these kinds of things, though, we want to factor them as much as possible just to see if any of the factors cancel out. So this I can factor using the little X puzzle and then the box afterwards, because there's a leading coefficient that's greater than 8. So the two things that multiply to give me 24, because 8 times 3 is where that 24 comes from. So the two things that multiply to give me 24 but add up to be this negative 14, the B term, are negative 2 and negative 12. So when I write the box or I do grouping, I'd have 8x squared still, I'd have plus 3 as well, but that negative 14x is going to split into negative 2x's and negative 12x's. And I'm just looking for a common factor for each column and each row. And once I've done that, what's on the outside will be my factors. So 4x minus 1 and 2x minus 3. This has a common factor of 4x. They're both divisible by 4 and an x. So when I divide out 4x from each of them, there's a 2x and a positive 1 left over. So remember, a way to check is, in my head, if I multiply this back out, I should get 8x squared, which I do, and 4x times 1 gives me 4x. So a common mistake there is forgetting that plus 1. The numerator here is a common factor of x, and when I divide out an x from each of them, I have 2x and plus 1 left over. And what we learned in this lesson is that when we multiply fractions, we multiply straight across. So all of this, I can think of this as just one giant fraction. All of this will be in the numerator, and everything, all the factors down here, will be the denominator. And anytime I have something like 2x minus 3, if I divide that by 2x minus 3, something divided by itself gives you 1. So these will cancel out. The 2x plus 1s will also cancel out. And those cancel out because this represents one number. We have two terms. But notice this x and this 4x are monomials. They're just one term. So I can use my rules for exponents that I learned the last unit to simplify this more, which is this x and this x have the same base. I can subtract their exponents, so there'd be no x's left. There'd be a 4 in the denominator. This was the only factor that I couldn't cancel out, so that would be my final answer. Right. H was an example of what you did in the 6.3 lesson. And so whenever I add and subtract, you have to have a common denominator. That doesn't matter for multiplying, but it does matter for adding and subtracting. And once again, just think back to some of those simple fractions where we looked at visuals for them. Things have to be the same kind of piece, the same size and shape in order to be able to add and subtract them. So that's what I'm doing here, is I'm making them the same kind of thing so that I can combine them together. So we look for the factors of each of the denominators, and then we look at what each of them are missing. So this isn't missing an x minus 2, and this one is missing that x minus 3. So I start by multiplying that in. Once I've done that, as long as my denominators are the same, I can rewrite this as one fraction. The denominator won't change, but I'll have 3x plus 6 plus 5x minus 15. And notice that if I have a positive here, a positive 1, distributing a positive 1 won't change the signs of these things. So I can combine my like terms to get 8x, and 6 and negative 15 combine to give me negative 9. So just like with the last lesson, the examples here increase in difficulty. So it's the same process, it's just to get you comfortable with the process and kind of slowly build up the difficulty along the way. And a lot of what we've done already is here. So you've basically done everything you need in order to understand this lesson. We're just kind of putting it all together. So if I'm solving a rational equation, and rational just means ratio, so an equation that has ratios or fractions, like this, I have two fractions, I'm going to start by creating a common denominator. So just like in the last lesson, I'm going to look at the factors of their denominators and see if they're missing anything. And if they are, I'll multiply each fraction by whatever factor it is missing or still needs. The only thing that's new and might be a little bit strange, so I'm going to show you, I'm going to illustrate it here, and I'll always highlight it in yellow just to be consistent, is once I've done that, I'm going to write an equation that is just about the numerators. And the reason for that is if I think about simple fractions, so if I have 1/3 and I say I'm going to add x thirds to that, and the end result was 4/3, the denominator isn't changing. That just shows us the sized piece that I have. So really, to solve this, I just focus on the numerator, and you can probably figure this out in your head. The only thing that this could be that would result in a 4 is a 3. So when I'm solving the equations, once the denominators are the same, this is the part that I'm focusing on to solve for x. So we're going to be writing an equation that is just about the numerators. Alright, so if I compare the denominators here, and I'm just putting parentheses around them to remind myself that this represents one number, I can see that they're the same. So I don't need to change anything about them. So then I'll just remember, okay, well in that case, if the denominators are the same, those aren't going to change. I just need to solve what's in the numerators. If I check the numerators here, I have x, and then my equal sign, and then 6. So that would actually be my answer. And that makes sense. If I replace this x with a 6, these look exactly the same. They're equal to each other. Alright, so we wrote an equation with just the numerators, and this one was a simple one, so it happened to already be solved. So if we take a look at the next one, my denominators here, 2 won't break down anymore. And then my second one just has an x. So they already have a common factor of x. This one needs a 2, and this needs nothing. So I'm going to multiply this this fraction by 2. So I'll have x minus 1 over 2x, and that equals 8 over 2x. They have a common denominator, so at this point, I'm writing an equation with just their numerators. So I'm going to say x minus 1 equals 8. And if you're not sure why I'm doing that, just think back to this really simple fraction. If they have the same denominator, then all I really need to do is figure out what number would this be to make it this, and that would have to be a 3 in order to get that 4. And so if I solve this now, I know that x equals 9. Alright, if I plug it in, I can see that that makes sense. 9 minus 1 will give me 8, and then they'll be the same. Alright, for the last one, the process is still the same, it's just we have 3 that we're comparing now. So we have a factor of x, a factor of 3, and a factor of 3 and x. And when you're comparing 3 fractions, it might help to start with whichever one has the most factors and just work your way up. So for this one, they each have a 3 in common already, so this one needs an x. For this one, they each have an x in common, so this one needs a 3. And if I check these two, this one needs an x, which we already gave to it, and this one needs a 3, which we've already given to it. And this needs nothing. So I'm going to multiply my first fraction by 3, my second fraction by x, and my last fraction by nothing. So 9 times 3 will give me 27. 2 times x will be 2x. Alright, and notice that my denominators are all the same. So really the part that I want to focus on is the numerators now. 27 plus 2x's should equal 18. And so all we're doing is solving the equation for the numerators. Alright, I'm trying to get x by itself, so I'm going to subtract 27 from both sides. I'm doing inverse operations when I'm solving. And that'll give me negative 9. And now I'm dividing by 2. Alright, and if you change this to a decimal, that's fine for this one, because it would give you negative 4.5. If you had a decimal that was one that was like repeating, or one that you had to round, leave your answer as a fraction instead, because you always want to give an exact answer. So in general, it's probably best to leave them as fractions, but certain ones like this, you can change it to negative 4.5 because you're not changing the value, you're not giving it a rounded answer, you're giving an exact answer. So take a moment and try the 3 problems on the back of this page. So pause the video, try them out, make sure that you're understanding this process, and then come back just to check and see how you did. Alright, so notice the first one, the denominators were the same. So in that case, you can rewrite this as an equation with just the numerators, and when you solve that, you get an x value of 5. And if I plug it back in, 5 times 5 gives me 25, so they're equal to each other now. So that's definitely right. For the second one, the second fraction needs a factor of x plus 3. So I'd be multiplying that in first, which gave me this. And now that I see their denominators are the same, I'm writing an equation that's just about the numerators, which I'm always going to highlight in yellow, just to kind of pull your eyes to that step. All right, and so when I solve this, I get negative 5 over 2. For the last one, when I compare all of the denominators, I could even write this out as 2 times 2 times x, but notice I'm going to try and make them all 4x in the end. So the first fraction needs nothing, the second fraction needs an x, and the last one needs a 4. So I started by multiplying an x to this one and a 4 to this one. Once the denominators are the same, I'm looking at the numerators and I'm solving that. So that I've highlighted in yellow. And then I'm just adding 1 to both sides and dividing out that negative 5. A common mistake here, so be careful, is this means minus 5x. So do make sure that that minus sign is in there. It'll change the sign of the answer that you get. All right. So we have just a couple more examples to do. And once again, the process is the same, it's just that the examples become slightly harder each time just to build up your skills. So we're still going to find the least common denominator for these. And once we know what our common denominator is going to be, we'll multiply each fraction by whatever factors it needs. And we're going to remember that we have to, in that point, write only the numerators as an equation. And once again, if you want to see why, it helps to give yourself a really simple example, because the process for harder ones is the same as simpler ones. So the one I used before was if I have 1/3 and then I add some sort of unknown number of thirds to this, and the end result is 4/3, that would have to be a 3. So really all you're doing is you're just solving this. The denominator isn't changing. We're looking at what value here makes this true, and that would have to be a 3. All right, once we've solved for our variables, the only thing that's more challenging about this example compared to the last one is we're going to talk about the fact that you can have extraneous solutions and how to solve for them or how to check for them. So I'll show you 2 ways to check, and you can choose which one you like the best. So the initial process is still the same. Notice that all of these are factored for me already. If you're comparing 3, it might help to start with the one that has the most. So these already have an x in common. This needs an x plus 2. If I compare these, this one already has an x plus 2, so it needs an x. And if I check these 2, they already have the ones that they're missing. And this needs none. So I'm going to multiply this first fraction by x, and this second fraction by x plus 2. So 2 times x will give me 2 x's. From that I'm subtracting, so 1 times x will be x, 1 times 2 will be 2, and then that'll equal negative 4. Once they all have the same denominator, just like we saw here, really all I need to do is just solve the numerator to figure out what that x value is that makes it the same. So I'm figuring out what x value, when I combine these together, will give me negative 4. So I'm going to rewrite this as an equation with just the numerator. Notice that I have subtraction, so be careful of that. That means minus whatever is in this fraction. So minus the x and the 2. So I'm going to put them in parentheses just to remind myself to give that minus sign to both of them, or to distribute it out, essentially. So I'll have 2x minus x, and then minus 2. Notice I have like terms, so that'll give me an x when I combine them. And now I'm just adding 2 to both sides. All right, so I got that as a solution. So the only other thing that's new and kind of different and extra here is I do need to check for extraneous solutions. So remember, in math, it's not possible to divide by 0. So when that happens, you get something that doesn't actually work. So if I pick just a random number, I'll do 7. If I try to divide it by 0, that gives me an error. So when I'm looking at more complicated fractions like this, the denominator isn't allowed to be 0. So the 2 ways that I can check my answer, just to make sure that they don't do that, one is to plug it into the denominator and see what happens. So I'm going to show you that here. So if I check that, if I replace the denominator wherever I see an x with a negative 2, it would look like that. And this is all numbers, so I would be doing order of operations. I'd be doing what's inside grouping symbols first, and negative 2 times 0 gives me 0. So what that tells me is this x value that I found as a solution isn't actually a solution because it makes the denominator 0. And as we saw, it's not actually possible to divide by 0. So at this point, I'd be able to say this is extraneous and it doesn't work. And since I don't have any other answers to check, that means that this particular equation has no solutions. All right, so that's option 1 for checking. Plugging it in, see if it makes the denominator 0. The only downside to that is if you get an answer that's a fraction, for example, if you don't like working with fractions, then it's going to get really annoying plugging those fractions in. So option number 2 for checking is to look at domain restrictions. And we've done that in a couple of units so far. Domain means x, and restriction means not allowed. So what we're doing is we're just checking which x values are not allowed, because which x values make the denominator 0. So I would just take the denominator and say that I know it's not allowed to equal 0 because dividing by 0, a denominator of 0, isn't possible. And the way I'd solve something like this where it's factored is I just take each of those factors and put it equal to this, and then solve. So right off the bat, I can see that x is not allowed to equal 0. That's one of the x values that makes the denominator 0. The other x value that makes the denominator 0 is negative 2. And so once I know which ones are not allowed, I would just go back and check my answer. If it's any of those, I'll know to cross them out. And so since negative 2 is not allowed, once again, this is an extraneous answer. And since I have no other solutions that I got from this, this particular equation would have no solution in that case. But if I got 2 different answers, it might be that they both work. Maybe both of them, if my 2 answers were 0 and negative 2, then they would both be extraneous and there'd be no solution. Or maybe just one of them doesn't work and then the other one does, and the other one would be the solution. All right, so at this point, go ahead and pause the video, try the next problem on your own, and just think about which of these methods you prefer in terms of checking to see if your solution is correct or whether it's extraneous. So you can plug it in and see if it makes the denominator 0. If it does, then it's extraneous. If it doesn't, then it's good. Or you can think about what x values are not allowed by putting the denominator equal to 0 and solving to see which x values do that, and just seeing if your answer is one of those. All right, so pause and then check the next one. All right, so I compared all the denominators. This one is missing a 3. Both of these are missing that x minus 2. So when I multiply 3 to the first fraction, I get 6 over this. When I multiply x minus 2 to the second one, 2x times x is 2x squared. 2x times negative 2 is negative 4x. Just be careful with the last one. You have 2 terms times 2 terms, so you might want to use the box or FOIL to do that. And so when I multiply those together and when I combine any like terms that I have, the final answer I have is there in blue, in light blue. Once I have a denominator that's the same for all of them, I'm going to write an equation that is just about the numerators. So I'll have 6 minus this whole thing. So notice I put the whole thing in parentheses to remind myself that I'm subtracting all of it. And that should equal x squared minus 5x plus 6. All right. And at this point, you would start to simplify a little bit. So when I distribute out that minus sign, the signs for each of these terms is going to change. It's now a negative 2x squared and a positive 4x. Things to think about at this point is, since I have an x squared in there, that makes this a quadratic. So think back to older units. We spent about 2 of them just on quadratics. So the way that we solve quadratics are things like quadratic formula, factoring, square roots, completing the square. So you have lots of options. But whatever method you choose, you're going to want all your terms to be on one side of the equal sign so you can decide what to do. So what I did is I went ahead and thought about inverse operations to get rid of these 3 terms and bring them over here. And the reason why I chose to bring things to this side of the equal sign is it's easiest to work with an x squared that's positive. So since it's positive here, I'm going to bring everything else over. So I'd be subtracting 6, I'd be adding 2x squared, and I'd be subtracting 4x. And I did that over here as well. So when I combine all my like terms, I ended up with this. Alright, so I have 2 things left over because those 6's canceled out. Once again, it's a quadratic, so you can factor, you can use quadratic formula, you could do completing the square. Well, this one, completing the square, won't work, but you have lots of options. In general, if there are only 2 terms, probably factoring or some other way will be easier than quadratic formula, but that would always work. If you do use the quadratic formula, keep in mind that a is 3, b is negative 9, and since there's no c term, c would be 0. I chose to factor this because I saw that it had a common factor and that would be really easy. And so when I solve now, I'm putting each of these factors equal to 0 and solving. Alright, so I got an x value of 0 and x value of 3. And my personal favorite way of checking is by doing the domain restrictions, but you don't have to do that. You can go back and plug in a 0 wherever you see x, and then work through it and see does it make the denominator 0, and then do the same thing with 3. Plug it in, see does it make the denominator 0. I choose to take the denominator and say that I know 3 times x minus 2. So 3 times x minus 2 is not allowed to equal 0. And when I put these things equal to 0, this doesn't have an x, so it's not going to allow me to solve for anything in terms of x values. So it's really just this one I'm putting equal to 0. And when I did that, I saw that x isn't allowed to equal 2. So when I put a 2 here, 2 minus 2 gives me 0. 3 times 0 is 0. So 2 is the x value that makes the denominator 0, which means these 2 are just fine. So both of those would be my solutions. All right, so our last example, in this case, is just increasing in difficulty, but nothing else is different. So it's still the same process. You just need to get comfortable with checking for extraneous solutions. And I'll use pink when I'm doing that just so it kind of stands out. And I'm going to always do the domain restriction to check for my solutions, but remember you're allowed to plug in your solutions in the denominator and see if it makes it 0. That's an option as well. So think about those denominators there, whether they factor more, how you would factor them. So I can see that the first one is a difference of squares. So the 2 factors there would be x plus 2 and x minus 2. This one's already factored. It's linear. It has an x with an exponent of 1. So that one's just x minus 2. So they already have that factor in common. This one needs an x plus 2. So I'm going to start by multiplying that in. Alright, I like to write the denominators factored, but if you choose to multiply them out, that's completely up to you. That's totally fine. A common mistake with this is forgetting that when I multiply 2 binomials together, that usually gives me 3 or 4 terms. And so you'd want to use the box or FOIL to do that. So for example, x times x will be x squared. So I'm showing FOIL this time. I show the box a lot. So if you like FOIL, then here's another example of it. X times 2 gives me 2x. 1 times x gives me 1x, and then 1 times 2 gives me 2. And if I combine my like terms now, that tells me for the second fraction, I'd have an x squared a positive 3x, and a positive 2 in my numerator. And my denominator, I'd have x plus 2 and x minus 2. So I can see that they have a common denominator now, so I'm just going to be writing an equation for their numerators. Right. And if you're not sure why I'm doing that, take a look back at the notes. I highlighted in yellow that step and showed a really simple example of why that's the case, where we're just focusing on the numerators at this point. So you can always rewind a little bit and find that spot. So before I go further, I want to look at what this is. Well, this is a quadratic, so I can solve it by factoring, quadratic formula, whatever I choose to do though. All of my terms need to be on the same side of the equal sign, and it's easiest if my x squared is positive. So I'm going to leave everything here. I'm going to bring these things over to them. So I'm going to subtract 3x's and subtract 6. So I have 0 on this side. Notice 3x minus 3x cancels out, and then I'm left with negative 4. Alright, so at this point you can solve, so think about all of the different options you have. So you can solve using factoring, quadratic formula, and it's been a while, but because I have the a term and the c term, another way to solve this that would be really easy is using square roots. So I'll show that now just as a reminder of how it works. Quadratic formula you did even in Algebra 1, and then solving using factoring, we've done that quite a bit as well. So when I'm solving using square roots, I'm getting the thing with the exponent, the square by itself. Alright, and the way that I undo an exponent of 2 is by taking the square root. When I'm solving an equation and I take an even root on both sides, I need to remember there are two possible answers to that. So x can be positive 2 or negative 2. So there's two solutions that I got to this one. So the last thing I need to do now is just check to see are both of those things solutions, is just one of them, or neither of them. And so I'm going to choose to check by finding the domain restrictions. And once again, domain means x, and restrictions means not allowed. So I'm just figuring out what x values aren't allowed because they make the denominator 0. So I'm going to start by taking the denominator and saying I know it's not allowed to equal 0, and figuring out what x values do that. So if I take each of these factors and put them not equal to 0, and then solve, I'll see that x is not allowed to equal negative 2, and x is also not allowed to equal positive 2. And the reason for that is if I go back and check, and I'll use a different piece of paper just to show you. So if I put in a positive 2 here for the x, 2 plus 2 gives me 4, 2 minus 2 gives me 0, and when I multiply those together I get 0. So positive 2 doesn't work. If I check negative 2, negative 2 plus 2, and negative 2 minus 2, so I'm replacing those x's with negative 2 and seeing what happens, I'll get 0 times negative 4, and same thing again, that gives me 0. So both of these make the denominator 0. So since I can see that here, or I can see that by plugging in, so remember this is option 1 and this is option 2, both of the solutions that I got do not work. They are extraneous. And since I have no other solutions that I got from this, that tells me that there isn't actually a solution to this one. Alright, so we're going to do one more example of this, and once again, it's not any harder, it's not any different in terms of the process, it's just that there are 3 fractions now, just to kind of review how to work with those, and also more factoring to work with. So if I look at the denominators for the next one, the first 2 are already factored for me. The last one is not, and so I'd want to think about when I have 3 terms, I can use the puzzle to do that. So I'm looking for 2 things that multiply to give me this negative 10, but then add up to 3, and those are going to be 5 and negative 2. Since this has a leading coefficient of 1, those are my factors, but if it was more than 1, I'd have to do the box or grouping afterwards to figure out how that coefficient splits between the 2 factors. But this one is just r plus 5 and r minus 2. So I can see they all have an r plus 5 in common, but these two are missing that r minus 2. And this is missing nothing. So I'm going to start by multiplying r minus 2 to each of them, the first two fractions. All right, so 1 times r gives me r, 1 times negative 2 gives me negative 2. 4 times r gives me 4r, 4 times negative 2 gives me negative 8. And then finally, I didn't need to change the last one, so it's still r plus 4. And even though I wrote the factors in a different order for this first one, they still have the same two factors throughout, so they have a common denominator. So now is when I'm going to be rewriting an equation that is just the numerator. And once again, if you're not sure why I'm doing that, rewind a little bit and look at some of the examples where I go through the steps at the beginning, and I highlighted in yellow a simple example that shows why we don't have to worry about the denominators at this point. So I have r plus 2, and I'm adding with that 4r minus 8, and that should equal r plus 4. Notice that if I distribute a positive 1 to these two numbers, it's not going to change the value. 1 times 4r is 4r, and 1 times negative 8 is still negative 8. So I don't actually need these parentheses here, but that's just as a reminder that if this were a minus sign, it would change the value of those things. So if I start to combine like terms now, I'll have 5 r's altogether on this side, and negative 2 plus negative 8 gives me negative 10. Notice this is not a quadratic. It doesn't have an r squared, so I don't have to worry about factoring or quadratic formula. I'm just going to solve it by getting all the r's on one side and all of the constants on the other. So 5r, when I take away an r, will give me 4 r's left over. R minus r cancels out, and 4 plus 10 is 14. So if I solve this now, I'm going to divide by 4. And notice that I reduced that down to get 7 over 2. All right, so at this point, the last thing I need to do, and I'm going to do this in pink so that it's kind of consistent, is I just need to check. So remember, an option is plug in 7 over 2, where you see an r in your denominator, and work it out. But I know I personally don't like working with fractions. I don't really want to do 7 over 2 minus 2 and 7 over 2 plus 5. So I'm going to choose to check it by looking for the domain restrictions. And domain means x, restriction means not allowed. So I'm just looking at what r values are not allowed because they make the denominator 0. This is already factored, so I can just put each of those factors not equal to 0 and see which ones don't work. Alright, so r is not allowed to equal negative 2 or negative 5, and my answer is neither one of those things, so it works. The reason why it's not allowed to be these two things is if I look back at the denominator here, if I were to check negative 2, when I replace these r's with a negative 2, and I simplify, I get negative, sorry, is that right? Sorry, that's supposed to be a positive 2. That's why it wasn't working out. Whoops. Okay, just kidding. So that's a positive 2. So when I replace these r's with positive 2s, positive 2 plus negative 2 gives me 0. 2 plus 5 gives me 7, and when I multiply those together, I get 0. So this positive 2 made the denominator 0, so that's not going to work. And if I check the negative 5 now, by plugging it into the denominator, so replacing r with negative 5, and there's another r, which I'll replace with negative 5, that gives me negative 7, but this gives me 0, and when I multiply anything by 0, it gives me 0. So this one also makes the denominator 0. That's why these are not allowed. That's why they're restricted. They're domain x values that are not allowed. But mine is neither of those, so I know that it actually is a solution. Alright, so take a moment to pause the video, try the questions on the back, and then come back to check and see how you did. Alright. So I factored out all the denominators, I looked at what each of them were missing, I multiplied that in, and then I rewrote an equation. Once they had a common denominator, I rewrote an equation that was just about the numerators. So I got this x value. I always choose to check by finding the domain restriction. So I said this denominator of 6x squared is not allowed to equal 0. And if I solve that, the only x value that does that is 0. And the answer I got is not 0, so I know that that is a solution and it will work. It's not extraneous. Alright, same thing again. I factored the denominators as much as possible. And when I compared them, these were each missing an x minus 5, and this was missing nothing. So I started by multiplying my first and my last fractions by x minus 5. Okay. And this is what I got. So once they have a common denominator, what's highlighted in yellow is my equation that's just about the numerators. Notice it's not a quadratic, so I'm just solving it like normal. I'm getting all the x's on one side and all of the constants on the other side. And I ended up with one answer, which was 26 over 5. I always choose to check by making the denominator equal to 0 by doing the domain restrictions. So I know that the two x values that make the denominator 0 are 2 and 5. Since my answer is neither of those, that means this really is a solution. It is not extraneous. It does work. Alright, for the last one, this was missing a factor of x, and this was missing a factor of x minus 3. So I started by multiplying those in. Once they had a common denominator, I went through and I made an equation that was just about the numerators. Be careful, make sure you're subtracting both of these terms, which is going to change the signs of them. That'll become a negative 5x and a positive 15. Alright, and once again, this is not a quadratic, so you can just solve it like a normal equation. But if there were an x squared in here, you'd have to do something like factoring or quadratic formula to solve. Alright, so when I solved, I got an x value of 3, but when I checked the domain restrictions, when I put this domain not equal to 0, the first factor, when I put it equal to 0, tells me that 0 is one of the things that makes this denominator 0, and 3 is the other value that makes the denominator 0. So since mine is not allowed, it's restricted, that makes this extraneous, and since I have no other solutions that I got, this would just have no solution. But if I had two x values, and one of them was something like 5 or 6, since that wouldn't be restricted, that would be my solution here. Alright, and once again, if you need help with any of this, feel free to come to Warhawk time or come see me after school. Just chat with me first so we can arrange a time. I sometimes have meetings after school. Alright.